In 5.4, talking about solving right triangles. And when you're asked to solve a triangle, what you're actually trying to do is find all the measurements of the sides and that of the angles. So here we have an example. We have this triangle ABC. Now, usually C is labeled for the hypotenuse, but probably in reality it really doesn't matter. You just start with one letter and you work and you just label them. So like for instance, here we have triangle ABC. So here we would start at one point and you'd usually go in one direction, doesn't matter, one way, and just label all three vertices. Usually C is labeled the 90-degree angle, so probably just go forward from now, just usually labeling the 90-degree angle C, so then there won't be any confusion later on. So I'll keep that habit up of doing labeling C my 90-degree angle. So that means little c, the opposite side of your angle is always the lowercase of whatever that is. So here we have little c, it's opposite of the big C, little a is opposite of the big A, and little b is opposite of that. That's the big thing, is always opposite sides are always labeled the lowercase of the opposite angles. So that's the big thing. Alright, so now we're trying to find what's the measurement of A, B, and C, and what are the sides and lengths of A, B, and C. So we always want to start with the given information that was given to us, and we want to avoid rounding until the very end. Okay, so try to not, when you find, say when we find B, we don't want it little b, we don't want to use that to find little a. We could do Pythagorean theorem, but we're probably going to have to round b at some point. So if we round that to find a, then we're off a little bit, right? It's not an exact number. Okay, so once you have your angles labeled and your sides labeled, then we want to figure out which trig function to use, sine, cosine, or tangent, based on the information we're given and the information we want to find. All right, so we're given a side. We're given a side C, which is the hypotenuse, because it's opposite of the 90. We're given this angle A, which we need to convert, instead of degrees, minutes, and seconds. We're going to convert that to decimal degrees. So 34 degrees, and then we want to add 30 over 60, right? Because there's 60 minutes in every 1 degree. So this is 34.5 degrees. Okay, and then so now we have A, and we want to find A or B, and we want to find both of them actually, but so it might be pick one of them, A or B. We'll find A first though, so that's opposite side of A. So we can go ahead and do sine. So sine of our angle, which is now 34.5 degrees, so make sure your calculator's in degrees, is equal to opposite, which is A, over the hypotenuse, which is 12.7. Multiply by both sides by 12.7, and then we can go ahead and enter this into our calculator, and that will give us our A. So A is equal to approximately 7.19, because we have 3 digits here, right? 3 significant figures, right? We have 3 here, so that's why I rounded at the hundreds place there. So there's our A, so we know A. Now we need to find side B and angle B. Well, 7.19 inches. So we can find B now. Because I rounded this right here, I don't want to use A, so that's why I don't want to do Pythagorean theorem to find B. So what I can do is I can use angle A again, if I want to. Or I could actually find angle B, right? Because this is 90, C is 90, so that means angle B and angle A have to add up to 90, right? So we can take 34.5 and minus that from 90. And so that's going to be something with a 0.5, right? So B is something with 0.5, and so that'd be 35, 40, 55.5. So 55.5 is angle B, so now we have all our angles, so that's one thing down, all angles are done, and now we just need side B for all sides to get done. So I could use I could use angle A still to find side B, or I could use B. So I could still stay with sine, so I could do it two different ways. I could do sine of 55.5 is equal to the opposite over hypotenuse, or I can do cosine of 34.5. Remember, these are cofunctions, right? And that is adjacent over hypotenuse. And multiply both sides, so these are going to give us the same answer, right? So 12.7 sine of 55.5 and 12.7 times cosine 34.5 will give us B as well, right? So these will both give us the same answer, and that answer is approximately out to 3 digits, 3 significant figures, not 3 digits. Sorry. Well, yeah, that is up to the 10th place because that's 3 significant figures. So there's B, there's approximately A. Oops, let's do that 0.19 inches. And then our angle B is the only one that we need to find, right? B. C is given to us, so if you want to put that in the list, that's fine. Angle B is 55.5 degrees. Angle A, they give to us, but you can put it in there, is 34.5 degrees. Angle C, we know is 90 degrees by the right angle. Okay, so that's how you solve given one side and an angle. Okay, so the second example is given two sides and an angle. So once again, it doesn't matter kind of how you label these A, B, and C. I would just probably get in the habit, most everybody does anyways, of putting C as your hypotenuse. That's just because of Pythagorean theorem, right? A squared plus B squared equals C squared. C squared is always the hypotenuse. So that means opposite of little c would be angle C, which is the big C. So that's why C is usually labeled the 90 degrees and the hypotenuse. Okay, so make sure your opposite sides are labeled correctly, like big A goes with little a, big B, little b would have to go down here. Okay, so now they give us two sides, and we're asked to find the other two angles and the remaining side, right? So we're going to have to do our trig functions here. First label, we could do Pythagorean. Here you can do Pythagorean theorem to find this angle. I mean side there. So you could use Pythagorean theorem and figure out what that side B is. That's fine because these are actually, they're what they are, right? Those are those measurements, so they're not being rounded. Those are what they give you. So you can go ahead and use that. So you can do that. I don't want to do that off the top of my head real quick, so I'll wait on that. But let's go ahead and find one of these sides, right? Or well, sorry, one of these angles. So we can find A or we can find B. Let's go ahead and find A. So what is little a in relationship to angle A? That'd be the opposite. And opposite of 90 degrees is the hypotenuse. So which trig function deals with opposite and hypotenuse? That's sine. Right, so sine of A, angle A, is equal to opposite over the hypotenuse, right? So that would be sine of A is equal to the 29.43 over 53.58. This means that there's 4 significant figures, right? So when we do round, we'll make sure we have 4 significant figures. Since I know you guys all love sig figs. Okay, but now we're finding the angle. Well, here we want to do inverse, so we're going to do sine inverse of our ratio here, 29.43 over 53.58, and that will give us the measurement of angle A. And so that measurement is approximately, right? So here's significant figures going to come in handy. 33.32. So there's 4 significant figures. So that's where we'll round it. So there is the angle. So I don't want to use that angle to find measurement of side B, but because I rounded it. But we can use that to find angle B would be fine, right? Because even if I do this real quick, I'll show you. So if I want angle B, this would be adjacent. And that would still be hypotenuse, so this would be a cosine, right? So that'd be cosine of B would equal adjacent 29.43 over the hypotenuse. So if I do this and enter this in, inverse cosine of this ratio, right, that would be using not this rounded number over here, but really you're still gonna get 68.68 and 56.8. You're still gonna get 56.8 when you type that in the calculator. So when you're finding angles, it's okay if you use this rounded number to find the third angle. Okay, so that's fine. It's just when you're finding a remaining side, even though really probably in reality you could use these numbers. Like on the last one, you could have used Pythagorean theorem, and you'd still be probably maybe correct. You're just not as well. It just depends on the problem. Sometimes you might get it if I asked you to do significant figures or round to the nearest hundredth or something like that. You may be off a little bit because of that rounding. So that's why, like in the book, it tells you to avoid rounding until the very end. So I would just stick with that. Don't round until the very end. But angles are okay because you only have one remaining angle, so might as well just minus that 33.32 from 90, right? And that's where you get the 56.68. Okay, so let's go ahead and find side B. You can do Pythagorean theorem, I don't care. That'd be 29.43 squared plus 53.52 squared. And that's going to give you C squared, or B squared, not sorry. Oh, so that means I actually need to subtract, right? Because we're finding B, not C, so we need to subtract those. And then we're going to have to square root that. And I take it that I did C squared here, so really I need the absolute value there. I would take the positive of that. So maybe add that, but subtract this one, right? Subtract the smaller one. And then we're going to have to square root that. Square root both sides. Although I don't really want to do that, so I'm going to go ahead and use one of my angles. Actually, all the preaching that I've just done about not using rounded ones, so I don't want to use these rounded ones because I just rounded those, right? So I probably want to do the Pythagorean theorem because I know I'd actually get a more accurate answer. And so that answer, using Pythagorean theorem, would give me B of approximately 44.77. So that would be the correct one. I guess I should listen to what I say, right? Don't use rounded things, rounded answers. Use what they give you from the start. Okay, so then you can practice these problems. Number 13 and number 23, and this would be on page 524. Okay, so we'll go ahead and do those problems now. Okay, so we're going to go ahead and solve the triangle ABC, and you notice in the directions on this homework that it says let C equal 90. So we go ahead and make sure that everybody agrees that C equals 90, so that means when we draw a triangle, this will be C and this will be little c. So then you can make A and B whichever one you want. You can make that A, you can make that B. That means this is little a and this is little b. Okay, so number 13 gives us A is 28.0 degrees, right? So that means there's 3 significant figures, just a point of reference. And then C is 17.4 feet. So there's our reference. So we want to find B, which we can go ahead and do right now because that's supposed to be 90, right? So if I add 2, that'd be 30, and 60 would be 90, so 62.0 degrees, right? Significant figures. So then they should give us, that was, well, yeah. And then we know C, right? C is 90 degrees. And now we know the hypotenuse, correct? C is our hypotenuse, so we know the hypotenuse, so we want to find little a. Degrees, and this would be 62 degrees. So we want to find A and B. Doesn't matter which one we do, we can find first. If we find A, we can use either angle A or angle B. Since I didn't round angle B to find it, then it's okay, right? So as long as you don't round one of your answers, then you can go ahead and use that. Okay, so we can do sine of A, angle A equals A over the hypotenuse, right? Because we're given the hypotenuse. Or I can do cosine of B, which is 62. So any of these will give us the same answer, 62, 62, not 68. Because these are co-functions, right? So that would be A over 17.4. So we can enter this in, multiply both sides by 17.4, even on both equations, on both of them, and we get A is equal to 8.17 feet. Okay, and now, like I said, now we would do find side B. We can do A, which is cosine of A, because B is now adjacent, side B is now adjacent over the hypotenuse. So I don't want to do tangent because I rounded this. So I don't want to do tangent, which would be tangent of 28 is equal to A over B. So I don't want to do tangent because I rounded this 8.17. Or I can do sine of B because I didn't round B, so I can actually use that. Or angle B, sorry. Right, so anyways, you multiply both of these by 17.4 and you get the same answer for B. And we'll go ahead and round that one as well. And that's 15.4 feet. So now we have all three angles and we have all three sides. We're done. Okay, now the last one, number 23. Okay, so here's number 23. Again, they just make reference that C is 90, and they give us A and they give us C. So I could have put A down here if I wanted to, but I put A to there. So that means that big A has to go in the opposite angle. So that means little b would go here and big B would go opposite of that, right there. Okay, so now we want to find these two angles. Well, we can do Pythagorean theorem to find B, but this time I have to take 46.3 squared minus 18.9 squared, and that will equal B squared. So I have to square those, subtract them, then go ahead and square root both sides to get B. And so then B is 42.3, because we have three significant figures again. So B is 42.3, and since again we rounded that, I don't want to use B to find angle B. To find angle B, I don't want to use little b because I rounded this answer. Same thing with A. I don't want to use side B. So I don't want to use side B to find those two remaining angles. Alright. Man, it's been a while since I did one of these videos, so sorry about it. Okay. So we want to find A, angle A, and I'm given side A. So that'd be opposite, so sine, because it's opposite over hypotenuse, because I'm given the opposite, and I'm given the hypotenuse. And now to find angles, I go in reverse, and I do inverse of this ratio of my opposite over the hypotenuse. And that's how I'm going to get angle A. And so angle A is equal to, or technically the measure of angle A, would be equal to 24. Let's see here, and 24.1. So A is the 24.1 degrees, or 24 and 6 minutes, something like that. So if you look in the back of the book, I think it's off. Back of the book, it says something like this. And 10 minutes. So 10 minutes is 0.17, actually 0.17 rounded. And when we do this, we get 24.09 rounded. Three significant figures is 24.1 degrees, which would be actually 6 minutes. So the back of the book is wrong here. So there's our answer, and then we can find our third one. So technically we do round this, but there's only 1 degree left, or 1 angle left. So B, you can just subtract that from 90, and we get 65.9 degrees. Okay.